Breaking news. The James Webb telescope has just detected something impossible. A constant glow on the night side of a planet 4 light-years away. Not natural, not random. A pattern that looks eerily like city lights. If this is real, we may not be alone, and what we're about to show you could change how we see the universe forever. What if the most important discovery in human history happened 4.24 light-years away? A small planet, barely bigger than Earth, quietly orbiting a dim red star. For years, Proxima B was just another name in a long list of exoplanets. A maybe, a what if. But everything changed when the James Webb Space Telescope locked eyes on it. Instead of the usual signals, like water vapor or methane, Webb found something far stranger. A faint, steady glow coming from the planet's night side. It wasn't flickering like a volcano. It wasn't dancing like auroras. It was constant, deliberate, artificial. Could we really be witnessing signs of an intelligent civilization lighting up its world, just like we do? Or is there something else, something even more mysterious, happening on Proxima B? In this video, we'll explore the scientific evidence, the mind-bending theories, and the ethical questions that no one wants to answer. We'll uncover how AI and the world's most advanced telescopes are working together, and why this discovery may redefine not just space exploration, but the future of humanity itself. Stay with us, because what you're about to learn will make you question everything you thought you knew about life in the universe. Proxima B. On paper, it's just another rocky planet orbiting a distant star. But when you take a closer look, when you really study the numbers, you realize just how incredibly close it is, and how strangely familiar. Located just 4.24 light-years from Earth, Proxima B is the closest known exoplanet to our solar system. That's right, closest. If you were to compress the scale of the universe into a map, Proxima B wouldn't even be on the next page. It'd be like the next block over. This planet orbits Proxima Centauri, a red dwarf star in the Alpha Centauri system, our stellar neighbor. But here's where things get even more interesting. Proxima B orbits its star inside what scientists call the habitable zone. That's the sweet spot. Not too hot, not too cold. The kind of place where, at least theoretically, liquid water could exist. And where there's water, there's the possibility of life. But before we get carried away, there's a big catch. Red dwarf stars like Proxima Centauri are not peaceful suns. They're chaotic, temperamental. They release powerful solar flares, waves of radiation that could easily rip away a planet's atmosphere. Imagine Earth getting hit by a solar storm 10 times stronger than anything in our recorded history. Every few weeks. That's the kind of space weather we're talking about. So while Proxima B sits in the habitable zone, there's always been a huge question mark. Does it even have an atmosphere left? Without one, any surface water would boil away, and life, as we know it, wouldn't stand a chance. Still, despite the risks, scientists never gave up on Proxima B, because even a small chance is still a chance. It's Earth-sized. It orbits its star every 11.2 days. It's likely rocky, and most importantly, it's reachable. Not tomorrow, not next year, but with enough time and the right technology, it's within the realm of human possibility. That's why when the James Webb Space Telescope was launched, one of its first targets was Proxima B. And what it found there was nothing like we expected. When scientists pointed the James Webb Space Telescope at Proxima B, they weren't expecting fireworks. The goal was simple: analyze the atmosphere, if it had one, and search for biosignatures like methane or oxygen. But what they found left them stunned. A faint glow, coming from the dark side of the planet. That alone was odd, but it wasn't the brightness that got their attention. It was the pattern. The glow wasn't scattered. It wasn't natural looking. It was uniform, structured, controlled. The data showed that the illumination was stable over time, unlike auroras or volcanic eruptions, which flicker and fade. This light source behaved more like artificial illumination. And here's the part that made scientists freeze in disbelief. The distribution of the glow matched the layout we might expect from concentrated clusters of energy use. In simple terms, it looked like city lights, not scattered randomly, but in localized regions, bright zones surrounded by dark, barren areas. It's the same pattern we see when we look at Earth from orbit. Cities lit up, nature left dark. And that raises an almost unthinkable question. Is something or someone living on Proxima B and lighting up the night? Now, before you jump to conclusions, scientists are cautiously skeptical. They've run simulations. They've ruled out known geological activity. The glow doesn't match heat from lava or plasma storms. Some have suggested exotic auroras, triggered by magnetic fields far more complex than Earth's. But even that theory struggles to explain the precision of the glow's distribution. And here's something even more fascinating. The glow only appears during certain rotational phases, almost as if it's being powered and then turned off. Could this be a technological signature, a kind of energy grid? We don't know. Not yet. But this is the first time in human history we've observed light behavior on another world that resembles the footprint of civilization. And if that's true, we may not be looking at just another rocky planet. We might be looking at proof, not of life in general, but of intelligent life, the kind that builds, the kind that powers cities, the kind that might just be looking back at us. If the glow on Proxima B is real, and if it's artificial, then the next question is both terrifying and thrilling. Who or what is creating it? There are several competing theories. Some are grounded in known science. Others push the very limits of our understanding. Let's start with the simplest idea. Perhaps the light is being generated by a present-day civilization, one that, like us, uses electricity to light up its cities. This would mean Proxima B hosts an advanced society capable of building infrastructure, generating energy, and controlling its environment. In this scenario, we're witnessing technological life, beings who may be thousands of years ahead or right at our level. Now imagine that. A parallel civilization, a cosmic neighbor living in the shadows, unnoticed, until now. But what if the glow doesn't belong to anyone living? That brings us to theory 2. The light could be a remnant, a civilization that once thrived and is now gone. What we're seeing could be the afterglow of technology left behind, still functioning, still emitting energy, even if its creators no longer exist. A dying grid, a world abandoned, which leads to the haunting possibility. What happened to them? Did they destroy themselves? Did their sun strip away their atmosphere? Or were they visited? And then there's theory 3, the wild card, that the light source isn't technological, but something entirely new, a form of bioluminescent life adapted to survive in darkness. Think of the deep ocean here on Earth, where creatures emit light to attract prey or mates. What if Proxima B's conditions forced evolution in a direction we've never imagined, creating massive light-emitting organisms across the planet's surface? It sounds bizarre, but remember, nature doesn't owe us explanations that fit our expectations. There's also a speculative theory among astrophysicists that what we're seeing is geoengineering on a planetary scale. Imagine a civilization that decided to terraform its world, lighting its dark side for warmth, growth, or survival. Structures built not for aesthetics, but necessity. Entire continents engineered. But let's not ignore the most sobering possibility, that we're simply misinterpreting the data, that this glow is caused by some exotic natural process we haven't encountered before. Something not artificial, just unknown. And that's what makes this so difficult. We have only data, no pictures, no sounds, no messages, just a steady light blinking at us from across the void, and a question no scientist can ignore. If it really is artificial, should we try to respond? If Proxima B really is showing signs of artificial light, then we're standing at the edge of the greatest leap in human exploration ever, because this changes everything. Up until now, space exploration has been driven by curiosity, science, and survival. But with this discovery, it becomes something else entirely, a potential first contact mission. And here's the kicker: Proxima B isn't some unreachable galaxy. It's right next door, astronomically speaking. At 4.24 light-years away, it's the closest star system to Earth. That means it's not just a target for telescopes anymore. It's a candidate for interstellar missions. In fact, some scientists believe that with next-gen propulsion, we could reach Proxima B within a single human lifetime. One project already in the works is Breakthrough Starshot, a bold initiative to send a fleet of light-powered nanocraft toward Proxima Centauri. These tiny spacecraft, no bigger than a smartphone, would ride laser beams from Earth, accelerating to 20% the speed of light. That's fast enough to reach the Proxima system in just over 20 years. Once there, they could take images, scan for biosignatures, and relay that data back home. This isn't science fiction. It's being designed right now by teams of physicists and engineers around the world. But here's the problem. Right now, our most advanced spacecraft, like Voyager 1, would take over 70,000 years to reach Proxima B. So any serious mission requires an entirely new kind of technology. And now, with the potential of artificial light on the surface, that urgency has skyrocketed. Agencies like NASA, ESA, and private firms like SpaceX are already rethinking their long-term strategies. Telescopes like the James Webb, the upcoming Nancy Grace Roman Space Telescope, and the extremely large telescope, ELT, in Chile, they're all being calibrated to look deeper, sharper, and farther than ever before. And Proxima B just jumped to the top of the list. Because if there's even a 1% chance that someone's out there, it changes the equation. The stakes are no longer theoretical. We're not just studying the stars. We're looking for neighbors. For decades, the search for life beyond Earth has been a scientific question, but now it's becoming an ethical one. If Proxima B is home to intelligent life, or even if it was, then every move we make going forward matters. The idea of contacting another civilization might sound thrilling, but history gives us reasons to be cautious. On Earth, when two civilizations meet, the outcome is rarely balanced. More often than not, the more advanced one dominates, even unintentionally. So what happens when humanity, the species that burned its own atmosphere and created nuclear weapons, decides to reach out into the dark? Do we send a message? Do we wait for a reply? Or do we stay silent? Some scientists argue that we have a moral obligation to observe, but not interfere. This idea is known as planetary protection, the principle that we should avoid contaminating other worlds with our own biological material, technology, or assumptions. Because if Proxima B holds life, even primitive life, Our presence could alter its course forever. But what if we do nothing? What if we simply watch and never engage? That leads to another ethical dilemma. If they are watching us, do they have the same restraint? Astrophysicist Neil deGrasse Tyson has often said that exploring space isn't just about what we'll find. It's about what it forces us to see about ourselves, our limitations, our decisions, our responsibilities. And nowhere is that more evident than in the debate over first contact. Some experts say we should prepare an international protocol, a universal agreement on what to do if contact is confirmed. But who decides? The United Nations, the world's most powerful governments, the scientific community, and how do we ensure that whoever speaks for Earth does so with caution, humility, and wisdom? Here's the uncomfortable truth. We are not ready. Technologically, philosophically, even emotionally, humanity has never faced a moment like this. And yet, that moment might already be unfolding. A flicker of light, a possible signal, a planet 4.24 light-years away that may be asking the same question we are. Are we alone? If they are advanced enough to emit controlled light, they might be advanced enough to detect us. Our satellites, our signals, our silence. Maybe they've already noticed. Maybe they're waiting to see what we do next. The glow on Proxima B might have never been noticed at all if it weren't for a new kind of explorer, not a human astronaut, not a space probe, but a line of code, a pattern recognition system powered by artificial intelligence, trained to analyze data so massive, so complex, that even the most brilliant scientists would take years to sort through it manually. You see, the James Webb Space Telescope sends back gigabytes of data every day. Infrared signals, spectroscopic breakdowns, thermal signatures, things the human eye could never detect, much less interpret. That's where AI comes in. Using machine learning models, these systems scan for anomalies, things that stand out from the noise. Not just what we expect to find, like methane, carbon dioxide, or water vapor, but things we never even thought to look for. And in the case of Proxima B, it flagged something unusual, a consistent glow, repeating patterns, emission behavior that didn't match any known atmospheric or geological profile. In other words, AI found something our brains might have dismissed. And it's not just Proxima B. AI has already been used to reanalyze older data from the Kepler and TESS missions, and in doing so, it discovered dozens of previously overlooked exoplanets. Why? Because machines don't get bored, they don't blink, they don't carry biases about what should be there. They see patterns, and when they do, humans pay attention. That's why some astronomers now argue that AI isn't just a tool, it's a partner, a collaborator in one of the most important missions in human history, finding out if we're alone. And as our tools evolve, so does our reach. Telescopes like the Nancy Grace Roman Space Telescope, expected to launch later this decade, will have even more powerful imaging systems designed specifically to work with AI for rapid analysis of exoplanet atmospheres. Meanwhile, Earth-based observatories like the extremely large telescope in Chile will use adaptive optics and real-time AI adjustments to observe distant planets with clarity we've never had before. The goal? Direct imaging, not just inferring a planet's existence through dim starlight, but actually seeing it. A real photo, a real surface, maybe even real cities. And here's the mind-bending part. The next big discovery might not come from a human. It might come from a neural network, a line of code quietly scanning the cosmos, watching patterns emerge, and whispering to us across space. You should take a look at this. Proxima B is more than a scientific curiosity. It's more than a distant world. It's a mirror, reflecting back some of the biggest questions we've ever asked. Are we alone? Are we unique? Or are we just one of many, living in the dark, searching for the light? For scientists, Proxima B represents hope, the hope that life is not a rare accident, but a cosmic pattern. For philosophers, it's a challenge, forcing us to confront what it means if we're not special, or what it means if we are. And for the rest of us, Proxima B is a reminder of how fragile our own world is. Think about it. We're here, spinning around a yellow star on a tiny blue dot, alive, breathing, thinking, surrounded by a universe so massive we can't even comprehend its edge. And yet, we've polluted our oceans, we've heated our skies, we've spent more energy on war than on wonder. Proxima B forces us to look outward, and in doing so, forces us to look inward. Because the search for other worlds, it always brings us back to our own. Neil deGrasse Tyson often says that astronomy is the most humbling of sciences. It doesn't just teach us about stars and galaxies. It teaches us perspective. It shows us that we are a speck, on a speck, orbiting a speck, in an unimaginable sea of specks. And yet, we are the speck that asks questions, that builds telescopes, that listens for signals, that wonders what's out there. Proxima B reminds us that the universe isn't empty. It's waiting to be discovered, waiting to be understood, waiting, maybe, to be met. So even if the glow we saw turns out to be natural, even if no civilization lives there today, Proxima B has already changed us. It has reignited a flame we almost forgot. The need to explore, not just for survival, but for meaning. Not just because we can, but because we must. A faint glow on the night side of a distant world, not flickering, not chaotic, but steady, consistent, like a heartbeat in the dark. Whether it's artificial or natural, alien or geological, one thing is clear: Proxima B has captured our imagination and challenged everything we thought we knew about the universe. For the first time in history, we may have detected light from a world we cannot touch. And if that light is truly coming from a civilization, past or present, then we are no longer the observers. We are the observed. Maybe the greatest discovery isn't the glow itself, but what it says about us. That we are a species that looks up, not just for answers, but for connection. We don't know what Proxima B really holds, but the fact that we're asking means the journey has already begun. And what comes next will change not just how we see the stars, but how we see ourselves. If this blew your mind, you haven't seen anything yet, because what we discovered next makes Proxima B look like just the beginning.